Welcome everyone to the next part while we shall discuss Reynolds number. So before discussing Reynolds number, let us discuss something about turbulent flow. That if suppose there is a streamline flow and if you keep on increasing the velocity of the liquid at some particular velocity of the liquid, the flow of the fluid will be behaving in a streamlined manner. That is, the flow will be streamlined. But above that particular velocity, if you allow the fluid to flow with a velocity above the particular velocity, the flow will be turbulent. So this velocity above which the flow is turbulent and up to which the velocity will be flowing in a streamlined manner, that velocity is called critical velocity. So this is a very important topic, critical velocity. So what is critical velocity? Let me sum it up for you. The velocity of a liquid, or let us say of a fluid, up to which the flow is steady but above which the flow becomes turbulent. So this is the critical velocity, right? So critical velocity can be expressed, the critical velocity, that is V critical, Vc. The expression of critical velocity actually depends upon, suppose a liquid is flowing through a tube and its critical velocity Vc depends upon three factors. One is the coefficient of viscosity, we will study about it in the chapter called viscosity, which is expressed by the term eta, and it depends on the density of the liquid. Let us use rho for it, and it depends on it's proportional to the diameter of the tube, the diameter, that is capital D of the tube, right? So Vc can be written as, Vc is equal to some constant, let us say R, right, into eta to the power x rho to the power y d to the power z. Actually, I have committed a mistake here. This is not actually proportional. It is actually dependent on. I meant try to mean here Vc. This Vc is dependent upon this. So these three are not factors are not linearly proportional to the thing. So I have considered the x, y, and z as the powers of eta, rho, and d. So Vc is equal to r eta to the power x, rho to the power y, and d to the power z. I just considered that. And what is Re? Re is the constant, and this is called actually the Reynolds number. Right? So with the principle of applying the principle of dimensional homogeneity, we can say that what is this Vc? Vc is a velocity. So velocity has the dimension of m to the power 0, l to the power 1, and t to the power minus 1. So that is equal to this eta. Eta has the dimensional formula. We shall be proving that in the chapter viscosity. So that is actually m L to the power minus 1 t to the power minus 1 whole to the power x multiplied by rho. Rho is what? Rho is density. Density is what? Mass by volume. So mass upon volume, that is m L to the power minus 3 whole to the power y. And d is diameter. So diameter is mere length. So L to the power z. Let us simplify it. So that is equal to m to the power 0, L to the power 1, t to the power minus 1, and that becomes here m to the power x. Here it comes m to the power x, and from this term, from this factor, it is m to the power y. So that becomes m to the power x plus y multiplied by L. Here comes L to the power minus n square to the power x. To the power minus x, right? Minus x. So that becomes minus x minus 3y here from this part, and here L to the power z. So that becomes plus z, and t is present in this part only. So t to the power minus x. So that is the dimensional formula of the right hand side. So using the principle of homogeneity, of dimensions, we can say that x plus y is equal to 0 minus x minus 3y plus z is equal to 1, and from the powers of t, minus 1 is equal to minus x. So this can be written as, from this we can write as x is equal to 1. So replace it here. So find that y is equal to minus 1, and replacing this y is equal to minus and x to the power 1 here, we shall find out that the minus is equal to minus 1, minus 3y is equal to plus 3, that is equal to z, which is equal to 1 again. So z is equal to minus 1. So we can find out, solving this equation, we are finding out that x is equal to 1, y is equal to minus 1, and z is equal to minus 1. So this critical velocity Vc can be written as the Reynolds number, the constant, into eta to the power x. So this becomes eta, and rho to the power minus 1, d to the power minus 1. So I can write it here, r eta divided by rho capital D. This is the formula for critical velocity. So the Reynolds number can be written as the Reynolds number r can be written as Vc rho d upon eta, right? So what is Vc? That Vc is the critical velocity, rho is the density of the fluid, and eta is the coefficient of viscosity of the liquid. So this is the definition of Reynolds number, right? So this Reynolds number, the R, is very much related with the critical velocity. So critical velocity is what? Below which the flow of the fluid is streamlined, and above which the velocity is the flow is turbulent. So with respect to the certain critical velocity, we will be finding its corresponding Reynolds number. So while the Reynolds number R is less than 1000, the flow is a streamline flow, right? And whenever the value exceeds 2000, okay, the flow becomes turbulent. And whenever the value is between 1000, between 1000 and 2000, the flow is almost unsteady. The flow is almost unsteady. So this value will differ from book to book, but in NCERT, this thing is written, right? This thing is written. In NCERT, I am for this data, I have taken this data from NCERT, right? So this is all about the critical velocity, Reynolds number, and the derivation of the Reynolds number with the help of the dimensional analysis. There is some other way to derive the expression for Reynolds number, but that is beyond the scope of your syllabus. So we shall discuss it in higher classes. Thank you everyone for joining. So let's meet in the next class.